Hello everyone, how are you all? I hope that all of you are doing amazingly great. First of all, welcome to this session. So today is the first lecture on trigonometric equation. What are we going to do today? The lecture goals for today is what are today's goals? See, trigonometric equation is a very easy topic. If you are well aware about trigonometry, you won't have any problem in this particular topic because there are only two topics that we need to understand in this chapter. Okay, that is particular solution and general solution. Particular solution and general solution. Okay. So if we have command over these two topics, we won't have any problem, and these two topics are very easy and very interesting chapter this one is. Okay, so without any further delay, let's get started with this chapter. Okay, now solution of a trigonometric equation. Basically, in this chapter, we will be solving equations in terms of trigonometric functions like sine x, cos x, tan x, right? So a value of the unknown angle which satisfies the given equation is called a solution of the trigonometric equation. Okay, so there are two types of solution. One is the principal solution, or we also call it particular solution. So principal solution is the solution of the trigonometric equation lying in the interval of 0 to 2 pi. If it is lying in this interval, then we call it a principal solution. Otherwise, general solution is basically, suppose if I write sine theta is equal to 0, right? So there are many angles theta which satisfies this particular equation. Like theta can be 0 over here, theta can be pi, theta can be 2 pi. So basically there are infinite solution to this equation, right? If I ask you how many solutions are there, you can say there are infinite solution to this equation. Now how do we write all of those infinite solution? That is basically the general solution. Okay, so I will tell you the way in which you can write all the infinite solution to a particular trigonometric equation, and that we will call as a general solution of the trigonometric equation. Okay, so we'll start. Okay, we'll get to know about this. Don't worry, just stick with me and keep learning. That's all. Okay, now, so first of all, let's start with some basic. Sin theta is equal to 0, cos theta is equal to 0, tan theta is equal to 0, and cot theta is equal to 0. What are the solutions of these trigonometric equation? So sin theta is equal to 0. Here theta is equal to n pi. Here theta is equal to n pi, where n is any integer, where n belongs to integer. Okay. Basically, if I put the value for n as 0, I will get 0 only. If I put the value for n as pi, I will get pi, then 2 pi, then 3 pi. Also, if I put the negative values of n like -1, -2, then we will get minus pi, -2 pi, -3 pi. So basically, all of these are the solution of sin theta is equal to 0, right? I hope all of you know that sin theta becomes 0 for theta is equal to 0, pi, 2 pi, 3 pi, 4 pi, and so on, and also minus pi, -2 pi, -3 pi, and so on, right? So I can write all of these solution in just one line, that is theta is equal to n pi, where n can be any integer. If you put n as 0, we will get 0 only. If you put n as 1, we are going to get pi. If n is equal to 2, we get 2 pi. So basically I am writing all of these solution this way. This is known as the general solution of this equation. Okay, now where is cos theta 0? Where is cos theta 0? So we know that cos theta is 0 at odd multiples of pi by 2, right? Odd multiples of pi by 2, like pi by 2, 3 pi by 2. Okay, cos theta is equal to 0 at theta is equal to pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, right? All of you know that. And also minus pi by 2, minus 3 pi by 2, minus 5 pi by 2, and so on. So there are again infinite solution to this particular equation, cos theta is equal to 0. There are infinite solution to this, and we can write all of these solutions like this. So the way to write all of these solution in general format goes like this: theta is equal to 2n plus 1 times pi by 2. As I told you that cos theta is 0 at odd multiple of pi by 2. So 2n plus 1 will be an odd number for any integer n, right? 2n plus 1 will be an odd number for any integer n. So at odd multiples of pi by 2, cos theta will be equal to 0. Simple, right? Now where is tan theta 0? So tan theta is 0 where sin theta is 0. So this equation 1 and equation 3 has the same solution, because basically tan theta is what? Tan theta is sin theta upon cos theta. Correct everyone? So when sin theta is 0, tan theta will also be 0. Correct? And we know that sin theta is 0 at theta is equal to n pi. So tan theta will be 0 at theta is equal to n pi. At theta is equal to n pi. Okay everyone? Now where is cot theta 0? Where is cot theta 0? Cot theta will be 0 where cos theta will be 0, because again cot theta is what? Cos theta upon sin theta. So cot theta, we know that this is equal to cos theta upon sin theta. So where cos theta is 0, cot theta will also be 0 over there, right? So cot theta is equal to 0, its solution will be same as the second equation. So theta is equal to 2n plus 1 multiplied by pi by 2. So here cot theta will be 0. So these are the general solution where each of these trigonometric function becomes 0. So always remember that sin theta becomes 0 at theta is equal to n pi, and tan theta also becomes 0 at theta is equal to n pi. Basically we call it integral multiple of pi. Okay, integral multiple of pi, where n is a basically integer, right? So sin theta and tan theta is 0 at integral multiple of pi, and cos theta and cot theta is 0 at odd multiple of pi by 2, which we write as 2n plus 1 multiplied by pi by 2. Okay, very simple. Now you might have this question, sir, where is sec theta and cos sec theta, sir? Right? Where does sec theta become 0, sir? Where does cos sec theta become 0? So, okay, we know that sec theta is never equal to 0. Cosec theta is never equal to 0. Okay, sec theta and cosec theta are never equal to 0. Do you know that? Okay, you might know this thing, that the range of sec theta is sec theta belongs to minus infinity to minus 1 union 1 to infinity, and the same is for cosec theta. Cosec theta belongs to minus infinity to minus 1 union 1 to infinity. So basically these two trigonometric functions, which two, sec theta and cosec theta, are either greater than or equal to 1. Either they are going to be greater than or equal to 1, or they are going to be less than or equal to minus 1. Their values never lie between minus 1 to 1. Okay, let me remind you again. See, we all of us know that sin theta and cos theta lies between, sin theta and cos theta lies between minus 1 to 1. Correct? If you don't know that, let me write all of these things over here. So sin theta and cos theta, both of these functions belongs to minus 1 to 1. Basically any value of theta you put over here, their values will be between minus 1 to 1. And cosec theta and sec theta, basically cosec theta is the reciprocal of sin theta, sec theta is the reciprocal of cos theta. So both of these functions lies between minus infinity to minus 1 union 1 to infinity. That will be their range. And if we talk about tan theta and cot theta, both of their range are from minus infinity to infinity. Basically they can attain any real number. They can be between minus infinity to plus infinity, tan theta and cot theta. So as you can see, cosec theta and sec theta can never become 0. So we have seen that where does sin theta become 0? Sin theta becomes 0 at integral multiple of pi. cos theta becomes 0 at odd multiples of pi by 2. And you know about tan theta and cot theta. Now cosec theta, sec theta never becomes 0. Okay, now let's solve few questions upon this concept. So if we want to find the general solution of sine 3 theta is equal to 0. Okay, so instead of sine theta, we have sine 3 theta. So we know that sine becomes 0 when the input inside is n pi. So here 3 theta will be equal to what? 3 theta will be integral multiple of pi. Here this angle 3 theta. This angle 3 theta will be integral multiple of pi. So theta will be equal to n pi by 3. N pi by 3. If 3 theta is equal to n pi, theta is equal to n pi by 3. Okay, this is the answer. Yes, this is the answer for this question. Okay, let me explain you again. See guys, all of us knows that to become sine 0, okay, sine of something is 0 when the input inside is integral multiple of pi. Okay, and here as we can see in this equation, the input is 3 theta. So 3 theta will be what? 3 theta will be integral multiple of pi. So 3 theta is equal to n pi, theta is equal to n pi by 3. I hope this is clear to all of you. Okay, let's move ahead to the next question. Sine 4x minus sine 2x is equal to 0. We want to write the general solution of this equation. What are the general solution of this equation? So first of all, I can apply sin c minus sin d formula over here. Okay, so all of us knows that sin c minus sin d is equal to what? Sin c minus sin d is equal to 2 times sine of c minus d by 2 multiplied by cos of c plus d by 2. This is the formula for sin c minus sin d. So I am applying over here. Sin 4x minus sin 2x will be, you also apply this formula with me, 2 times sine of 4x minus 2x by 2, which is basically c minus d by 2, multiplied by cos of c plus d by 2, which is 4x plus 2x by 2 is equal to 0. Okay, so I have applied this formula, the formula for sin c minus sin d. Okay everyone, so 2 sin c minus d by 2 multiplied by cos of c plus d by 2. So here we have 2 times sine of 4x minus 2x will be 2x, 2x upon 2 will be x. So 2 times sine x, and here we have 4x plus 2x, 6x by 2, that will be 3x multiplied by cos of 3x is equal to 0. Okay, now we can write its solution. See, if the product of two things is equal to 0, so either this thing will be 0 or this thing will be 0, right? So from here we can comment that either sin x will be 0, either sin x will be 0 or cos of 3x will be 0, or cos of 3x will be 0. So that's the thing. So either sin x will be 0 or cos of 3x will be 0. If the product of two things is equal to 0, so either this will be 0 or this will be 0, or both of them will be 0, right? That's the thing. So we can get solutions from this part. Sin x is equal to 0. So what are the values of x which satisfies this equation? Can you find that out? And also include in those solutions the solutions that we get from this particular equation, like where cos 3x is equal to 0. Okay, so first of all, let me write the solution for sin x is equal to 0. So we know that sin x will be 0 when x will be equal to n pi. X will be equal to integral multiple of pi. So there sin x will be 0. And if I write cos 3x is equal to 0, so we know that cos theta is 0 when the input inside cos is odd multiple of pi by 2. So here 3x will be equal to 2n plus 1 times pi by 2, right? This input 3x will be equal to odd multiple of pi by 2. So 3x is equal to 2n plus 1 times pi by 2. So from here I can say that x is equal to 2n plus 1 times, if you divide by 3, we get pi by 6, right? 2 multiplied by 3, that will be 6. So x is equal to 2n plus 1 times pi by 6. So now our final answer for this question, these are the solution which satisfies this equation. These are also the solution which are satisfying the equation. So we are going to take union of these two solutions. Basically, we want to include these one. Yes, these solution satisfies this equation. For x is equal to n pi, this thing will be 0. For x is equal to n pi, this thing will be 0. And for x is equal to 2n plus 1 times pi by 6, this thing will be equal to 0. So our final solution, our final answer is going to be, so theta is equal to n pi union, okay, integral multiple of pi and taking its union with 2n plus 1 times pi by 6, okay, or we can write it like this, theta is equal to n pi union 2n plus 1 times pi by 6. So this is our final answer for this question. Okay, so we are getting integral multiple of pi's as well as these solution. Are we clear about this? Okay, now moving ahead. Tan of 3 theta by 4 is equal to 0. So again we know that tan is 0 when the input inside it, the 3 theta by 4, that's the input, right? The input should be equal to what? The input should be equal to integral multiple of pi. So here the value for theta will be, okay, if you multiply this 3 by 4 to the right hand side, we get 4 n pi by 3. These are the values of theta. This is our answer for this question. Okay, clear, simple. Let's move ahead. Cos of x by 2 is equal to 0. So we know that cos becomes 0 when the input inside it, which is x by 2. X by 2 should be equal to what? Odd multiple of pi by 2. So 2n plus 1 times pi by 2. Okay. So x by 2 is equal to 2n plus 1 times pi by 2. So x will be 2n plus 1 times pi. This is our answer for this question. X will be equal to 2n plus 1 times pi. Okay. Now, let's move ahead. Tan 2x plus tan x upon 1 minus tan x multiplied by tan 2x is equal to 0. So we want to find the solution of this equation. Okay. So here I can see the formula of tan of a plus b. Do you know the formula for tan of a plus b? Yes. So that will be equal to tan a plus tan b upon 1 minus tan a multiplied by tan b. So tan a plus tan b upon 1 minus tan a into tan b. So tan 2x plus tan x upon 1 minus tan x into tan 2x. It looks like this, right? Here a is this angle 2x, b is this angle x. So here we can apply this formula that tan a plus tan b upon 1 minus tan a tan b, that will be tan of a plus b. That will be tan of 2x plus x, right? Do you get it? See, if you expand this thing, you get this, right? If you expand tan of 2x plus x, you get this, right? Tan of 2x plus x will be tan of 2x plus tan of x upon 1 minus tan x into tan 2x, right? So I have, compressed this thing to this thing. Yeah, this is tan of 2x plus x is equal to 0. Basically, this is tan of 3x is equal to 0, right? 2x plus x will be 3x. So tan of 3x is equal to 0. Now we can easily write its general solution, that here 3x is equal to what? 3x will be equal to integral multiple of pi, because tan is 0 at integral multiple of pi. So x will be equal to what? X will be equal to n pi by 3. So this is the general solution. I hope you understand what does general solution means. Basically, this is all the solutions which satisfies this equation. If you put n is equal to 0, we get the values of x as what? 0 only. And more angles, if I put n as 1, I get pi by 3. If I put n as 2, I get 2 pi by 3. If I put n as 3, I get 3 pi by 3. Then 4 pi by 3 and so on. And I can also put the negative values of n, minus 1, minus 2, minus 3. Then also we get many solutions, right? Minus pi by 3, minus 2 pi by 3 and so on. So basically, instead of writing all of these solutions, okay, because there are infinite solutions, we can compress all of them and write it like this, that theta is equal to n pi by 3, where n belongs to integer. N can be any integer over here. right? Simple. Let's move ahead. Like, see in this question, tan of 3x minus tan of x upon 1 plus tan of 3x multiplied by tan of x is equal to 0. So here I hope you can see that pattern, that this is the formula for tan of c minus d. If I expand tan of c minus d, I get tan c minus tan d upon 1 plus tan c multiplied by tan d, right? This is what I get. So I can compress this thing. I can write it like this, that this is basically tan of 3x minus x. Okay. This entire thing is basically the expansion of this one, right? Basically, if you expand tan of 3x minus x, you get this. Tan of 3x minus x will be tan 3x minus tan x upon 1 plus tan 3x into tan x. Correct. Yeah. Okay. Now, so I have compressed it like this, that this is nothing but tan of 3x minus x. Tan of 3x minus x will be tan of 2x. So here we have that tan of 2x is equal to 0, and tan of something will be 0 when this thing 2x is equal to what? Integral multiple of pi, right? 2x will be equal to n pi, so x will be equal to n pi by 2. Now this particular example is very, very important. Let me mark 3 star on this example. Why, sir? What's different in this example? What's different in this example? See, this is not our final answer. This is not our final answer yet. Because see, whenever there is like tan in the picture, whenever there is like cot in the picture, we have to make sure that whatever solution we get, okay, they are in the domain of this function, right? I hope all of you know that in tan theta, theta cannot be equal to odd multiple of pi by 2, because there tan theta is not defined. Okay, so you can write it like this, that tan theta is not defined at where? Tan theta is not defined at theta is equal to 2n plus 1 times pi by 2. I hope all of you know that tan pi by 2, its value is not defined. We say that it's infinity. So basically infinity is not defined, right? So in tan theta, we can't put theta angle as exactly pi by 2. Okay. Even if you ask calculator what is the value for tan pi by 2, it will show you error. It will show you error. If you ask computer or calculator what's the value for tan 3 pi by 2, it will show you error. Why? Because that is not defined. So tan theta is not defined at this. Okay. What else is not defined at this? Sec theta is also not defined. Sec theta and tan theta, right? Tan theta and sec theta you can write. Sec theta and tan theta are not defined at theta is equal to this. Another important point that you should note, which is about cot theta and cosec theta. Cot theta and cosec theta are not defined. Where? At theta is equal to n pi. At theta is equal to n pi, these two things will not be defined. See, there is a very simple logic behind it. Why they are not defined? Because we know that cot theta is what? Cot theta is cos theta upon sin theta. Everybody knows that? Yes? What happens at n pi? At n pi, this denominator, what's the denominator? Sin theta. That becomes 0. This denominator becomes 0 at n pi. So cot theta naturally will not be defined for these angles, for theta is equal to n pi. In the similar way, cosec theta will not be defined at theta is equal to n pi, because cosec theta is 1 upon sin theta. And then again, sin theta becomes 0 at theta is equal to n pi, so it will not be defined. Okay, now, so considering these points, I hope you understand this concept. What's the problem over here? That if I put the value for n as 1, I get pi by 2. If I put the value for n as 3, I get 3 pi by 2. At 5, I get 5 pi by 2. What's the problem at these angles? See, here we have tan x, right? Here I can't put x as pi by 2. Can I put x as pi by 2? No, I can't. because tan x will not be defined. I can't put x as 3 pi by 2, right? So here we need to exclude these angles, right? X cannot be equal to pi by 2 or 3 pi by 2 or 5 pi by 2 and so on. We have to exclude these angles. So we are getting this solution, and from this solution we want to remove these angles. Basically we can't take these angles in our solution. So what value of n should I be putting over here? So you can say that, sir, we can put n as even number, but we can't put n as odd number over here, right? Here n cannot be equal to an odd number, right? So I can put the value for n, where n, here I can put n as 0. There won't be any problem at 0, right? X becomes 0, that's fine, right? Tan x is defined for x is equal to 0. I can put the value for n as 2 as well, because at n is equal to 2, we are getting 2 pi by 2. 2 pi by 2 is what? Pi. So I can put x as pi. I can put n as 4 or 6 or 8, basically where n is an even number. Where n is an even number. N has to be an even number over here. Because if n is not an even number, this question itself fails. We can't even write tan x in that case. So whenever we have like tan x or cot x or sec x or cosec x and we get the solution, then after getting the final solution, you have to make sure that you are not including those values, you are not including those angles where these trigonometric functions are not even defined. So that's why I am saying that you can put n as even number only over here, okay, where n is equal to an even number, or you can put any even number as 2k. You can put n as 2k, right? So if I put n as 2k, I get the final solution as x is equal to 2k times pi by 2, which is k pi. This is our solution. This is our answer. X is equal to k pi, where k is any integer. Now I can put the value for k as 0 or 1 or 2 or 3 or 4 or anything. See, if I put k as 0, I get 0 only. At k is equal to 1, I get pi. At k is equal to 2, I get 2 pi, 3 pi, 4 pi. That works. Okay. So I hope you understand the crux of this question. The crux is, see, in this solution, we are getting many angles, right? We are getting all of these angles also for odd values of n. That is why we have to make sure that n is an even number, and any even number you can consider as 2k. So if n barabar 2k, okay, if you put n as 2k, what do I get? X barabar 2k times pi by 2, and 2 will get cancelled out and we will get pi. See, if I put n as 2k over here, I get 2k times pi by 2. 2 gets cancelled out, we get k pi. So this is our solution for this particular question. So this is not the final answer. This is the final answer. Integral multiple of pi. I hope that this is clear to all of you. Okay. Now, moving ahead. So we have talked about general solution, right? Now let's talk about principal solution. Principal solution. Okay. Okay, so now let's talk about principal solution, which is very easy. So as I told you, principal solutions are those solutions which is in the interval of 0 to 2 pi. Here theta will be in the interval of 0 to 2 pi. Okay, those type of solutions are known as principal solution. Okay, suppose if I ask you, find principal solution of sine x is equal to 1 by 2. Okay, find the principal solution of this equation where sine x is equal to 1 by 2. Okay, so we know that sine x becomes 1 by 2 in the first quadrant and then in the second quadrant. because these are the two quadrants where sin x will give you positive values. Okay, I hope everybody knows that in the third quadrant and in the fourth quadrant sin x gives you negative value. So in the first and second quadrant, sin x is going to give you positive values. So sin x is equal to 1 by 2 in the first quadrant at x is equal to what? At x is equal to pi by 6, or we can call it 30 degrees, right? So at x is equal to pi by 6, we know that sin x becomes 1 by 2, and then again sin x becomes 1 by 2 in the second quadrant, and that angle is pi minus pi by 6, right? Because we know that sine of pi minus theta and sine of theta gives you the same value. Basically sine of pi by 6 and sine of pi minus pi by 6, both of their values are what? Same. Okay, so x is equal to pi by 6 or x is equal to what? 5 pi by 6. These are the solutions of this equation. So only two solutions, yes, because we are only looking for solution in this interval. So these are known as particular solution. Later on we will also understand how to write the general solution of this equation. Of course there are not only two solutions, right? There are infinite solution to this equation. There are infinite solution to this equation. We will learn that how to write all of those infinite solution. But before learning that, you have to learn how to write particular solution, because that would be the first step. Before finding general solution, you need to understand how to find this principal solution, which are the solutions in the interval of 0 to 2 pi. Okay, so sin x becomes 1 by 2 at pi by 6 and 5 pi by 6. Let's take few more examples. The next example, suppose if I write sin x is equal to minus 1 by 2, what are the principal solution? Okay, let me write the question. Find principal solution. Find principal solution. Okay, so question number 1, sin x is equal to minus 1 by 2. Okay, so sin x will give you negative values in the third quadrant and in the fourth quadrant. So there will be two solutions again, right? If I am looking for principal solution in the interval of 0 to 2 pi. So what are those solutions? So sin x is negative. Okay, we know that sine of pi plus theta, we know that sine of pi plus theta is equal to minus sine theta, right? And sine of 2 pi minus theta is also equal to what? Minus sine theta. Sine of pi plus theta will be equal to minus sine theta because this is an angle of third quadrant. Here sine will give you negative values. Sine of 2 pi minus theta, 2 pi minus theta is an angle in the fourth quadrant. Here again sine will give you negative values, correct? Okay, so sine of pi plus theta, as we know that this is equal to minus sine theta. So that is why the solution for this equation is going to go like this, that x is equal to pi plus pi by 6 and 2 pi minus pi by 6. These are the two solutions, right? Pi plus pi by 6 will be 7 pi by 6 and 2 pi minus pi by 6. If you take LCM, 6 2s are 12, 12 minus 1, 11. So this will be equal to 11 pi by 6. So these are the two values of x we get, 7 pi by 6 and 11 pi by 6. At these two angles, sin x will be minus 1 by 2. Because again sin pi plus theta is equal to minus sine theta. Okay, sine of pi plus pi by 6 is equal to minus sine pi by 6. Sine of 2 pi minus pi by 6 will be equal to minus sine pi by 6, where sine pi by 6 is 1 by 2. So the answer for this question is pi plus pi by 6 and 2 pi minus pi by 6. Okay, now let me ask you another question. Cos theta is equal to 1 by 2. So first of all, positive value, yeah, positive value, first quadrant and which quadrant? And fourth quadrant. Cos theta is positive in the first quadrant and then again in fourth quadrant. Okay, at what value of theta cos will be equal to 1 by 2? So in the first quadrant we know 60 degree, or we can call it pi by 3. So theta will be equal to what? Theta will be equal to what? Pi by 3, because we know that cos of pi by 3 is equal to what? 1 by 2, or theta will be equal to 2 pi minus pi by 3. This is in the fourth quadrant. See, this is the first quadrant solution, this is the fourth quadrant solution, because we know that cos of 2 pi minus theta, cos of 2 pi minus theta is equal to cos of theta. So cos of 2 pi minus pi by 3 will be equal to cos of pi by 3. Okay, so we are getting two values of theta over here. Theta is equal to pi by 3, or 2 pi minus pi by 3, which is what? 3 to the 6, 6 minus 1, 5, 5 pi by 3. So these are the two values of theta we are getting as our answer. Simple. Let's take few more examples. Third example. If I ask you tan theta, okay, let's take another example of cos only. Cos theta is equal to some negative number minus root 3 by 2. Okay. So now first of all think about the quadrant. In which quadrant cos theta will give you negative values? So in the second and in the third quadrant. Okay. We know that cos theta is equal to root 3 by 2 for theta is equal to pi by 6. We know that cos pi by 6 is root 3 by 2. Correct, everybody? We know cos pi by 6 is equal to root 3 by 2. Okay. So to give it in negative values, we have to look for an angle in the second quadrant and in the third quadrant. In the second quadrant, that angle is going to be, can you tell me what angle? In the second quadrant, that angle is going to be pi minus pi by 6. Okay, pi minus theta. Pi minus theta angle will be an angle of second quadrant. We know that cos of pi minus theta is minus cos theta. Cos of pi minus pi by 6 will be minus cos pi by 6. So this is one of the angle, and another angle in the third quadrant, that will be pi plus pi by 6. Okay. So we are getting the values of theta as 5 pi by 6, and this will be 7 pi by 6. These are the two values of theta we are getting, 5 pi by 6 and 7 pi by 6. Let me again repeat it. See guys, all of us knows that cos pi minus theta is equal to what? Minus cos theta, right? Negative values in the second quadrant. Same way, cos pi plus theta will be an angle in the third quadrant. Pi minus theta second, pi plus theta third quadrant angle. Okay, so cos of pi plus theta is also equal to minus cos theta. That's what I am saying over here. Okay, so one of those angles pi minus theta, another angle pi plus theta. We are looking for negative values. We are looking in the second quadrant and in the third quadrant. So these are the two principal solution of this equation. Okay, let's practice few more questions. Let's take an example of tan theta. Tan theta is equal to, let's say, 1. So tan theta will be equal to 1, a positive value, right? Which quadrants will be looking for? Will be looking for in the first quadrant, because there it will be positive, and then again it will be positive in the third quadrant. So in the first quadrant we know that theta will be equal to pi by 4. Okay, tan of pi by 4 is equal to 1. What will be the angle in the third quadrant? The third quadrant angle will be pi plus pi by 4. Pi plus pi by 4, right? Pi plus pi by 4 will be in the third quadrant. So this is pi by 4 and 5 pi by 4. These are the two values of theta we are getting. Theta is equal to pi by 4 and 5 pi by 4. First quadrant and the third quadrant. Okay, let me write the reason behind it. I hope all of you know that tan of pi plus theta is equal to tan of theta. Positive values in the third quadrant. Okay, the value for tan pi by 4 or tan pi plus pi by 4 will be same. Both of their values will be 1. Tan pi by 4 or tan 5 pi by 4, both of their values will be 1. Okay, let me write another equation. Tan theta is equal to minus root 3. Okay, negative angle. Okay, now negative angle, which quadrant we will be looking for in? We'll be looking for in second quadrant and in the fourth quadrant, because tan is positive in the third, right? And first, of course. So in the first and third, tan is positive. In the second and fourth, tan is negative. We know that the value for, okay, we know that value of tan pi by 3 is what? The value for tan pi by 3 is root 3. Okay, the value for tan of pi by 3 is equal to root 3. So the angle we will be looking for will be in the second quadrant. That angle will be what? In the second quadrant, that angle is going to be pi minus pi by 3. Okay, this is an angle in the second quadrant. Here tan will be giving the value minus root 3, and another angle in the fourth quadrant, that will be 2 pi minus pi by 3. These are the two solutions. So pi minus pi by 3, its value is 2 pi by 3, which is an angle of the second quadrant. 2 pi minus pi by 3, if you take LCM, its value is 5 pi by 3, which is an angle in the fourth quadrant. So these are the solutions of this equation, 2 pi by 3 and 5 pi by 3. Okay, tan theta gives us negative values in these two quadrants. Okay, let me write the formula. We know that tan of pi minus theta, okay, is minus tan theta, and tan of 2 pi minus theta is also minus tan theta. See, pi minus theta is an angle in the second quadrant. That is why we know that in the second quadrant tan is negative. 2 pi minus theta is an angle in the fourth quadrant. So this is second, this is fourth. So in the second and fourth quadrant, tan gives you negative values. Tan of pi minus pi by 3 is equal to minus tan pi by 3, where tan pi by 3 is root 3. Minus tan pi by 3 will be minus root 3. Correct? Tan of 2 pi minus pi by 3 will be equal to, right, minus tan pi by 3. So these are the two answers for this equation. I hope all of you gets it. Okay, now see, let's move forward to the next topic, which is the general solution of trigonometric equation. Okay, let's move on to that part, which is amazing, which is very important. Okay, I hope you have learned about the principal solution. Now let's talk about the general solution. There are some formulas which you need to follow in this. Yes, simply you have to learn few formulas, and then this topic will be clear to all of you. Okay, so the formula is, first of all, sine theta is equal to sine alpha. Sine theta is equal to sine alpha. So here theta is equal to n pi plus minus 1 raised to the power n times alpha. Theta is equal to n pi plus minus 1 raised to the power n times alpha. Okay, this is the general solution of this equation. Sine theta is equal to sine alpha. Theta is equal to n pi plus minus 1 raised to the power n multiplied by alpha, where n can be any integer. See, if you put n as 1, okay, if you put n as 1, we get theta is equal to pi minus alpha. If you put n as 2, we get theta is equal to 2 pi plus alpha, right? If you put n as 2, we get 2 pi, and minus 1 raised to the power 2 will be plus 1. That is why there is plus over here. Okay, if you put n as 3, we get theta is equal to what? 3 pi minus alpha. Okay, because 3 pi and minus 1 raised to the power 3, minus 1 raised to the power 3 will be minus 1. So we have 3 pi minus alpha and so on. So these are the solutions we get. Theta is equal to pi minus alpha, 2 pi plus alpha, 3 pi minus alpha, and so on. And we can write all of these solutions like this. That theta is equal to n pi plus minus 1 raised to the power n times alpha. You don't have to worry about the proof behind it. Okay, its proof is not that difficult, but its proof is not at all important. That is why we are not going into the proof. Okay, I can give you an idea about the proof, that how we derived these things, how this formula was derived. I can give you an idea behind the proof. Okay, so the idea behind proof goes like this. See, sine theta is equal to sine alpha. We can bring sine alpha to the left hand side. We get sine theta minus sine alpha is equal to 0. Then we can apply the formula for sine c minus sine d. Okay, which is 2 times sine of c minus d by 2 theta minus alpha by 2 multiplied by cos of theta plus alpha by 2 is equal to 0. Now, the product of two things is 0. So, either this thing is going to 0. And now we know that this thing becomes 0 when this thing is equal to n pi, this input is n pi, then this will be 0. So, and cos will be 0, okay, either this thing will be 0. And this is 0 when theta plus alpha by 2 is odd multiple of pi by 2. So, if we get the solutions from this equation and this equation, combine those solutions, we get to this. So, this is the idea behind proof. You don't have to, learn the entire proof, because not at all important, but you have to remember the direct formula, that sine theta is equal to sine alpha. Its formula is theta is equal to n pi plus minus 1 raised to the power n times alpha. Never forget the solution, and you won't forget it because we will practice many equations on it. So, there is no chance that you can forget this formula after practicing equations. Okay, so this is the first formula. Okay, now let's write the second one. Second one is cos theta is equal to cos alpha. So, cos theta is equal to cos alpha. The solution for this equation, its solution are going to be, okay, its solution are theta is equal to 2n pi plus minus alpha. These are the solution of this equation. Theta is equal to 2n pi plus minus alpha. Again, you have to directly remember this. I hope you understand the idea behind this proof as well. This has been proved in the similar way. You bring cos alpha to the left hand side, then cos theta minus cos alpha is equal to 0. There you apply the formula for cos c minus cos d, and there you can, okay, from there you can prove it. So, simply just remember the final formula, okay, that theta is equal to 2n pi plus minus alpha. Third, tan theta is equal to tan alpha, okay, tan theta is equal to tan alpha, and its solutions are theta is equal to n pi plus alpha. These are the solution for this equation. Tan theta is equal to tan alpha, its solution are theta is equal to n pi plus alpha. Okay, simple. Now, only 3 formulas that you have to remember. Okay, the formula for, you can note it down, that formula for cosec theta is equal to cosec alpha is same as sin theta is equal to sin alpha. Okay, both of their solutions are same, because cosec theta is equal to cosec alpha. Cosec theta is 1 upon sin theta, cosec alpha is 1 upon sin alpha. We get to this equation only. Okay, so their solutions are same. Similarly, you can guess it, that the formula for like cot theta is equal to cot alpha. Basically, this is what? If you write cot theta as 1 upon tan theta, cot alpha is 1 upon tan alpha. So, this is same as, right, is same as tan theta is equal to tan alpha. Okay. In the similar way, formula for, formula for sec theta is equal to sec alpha is same as cos theta is equal to cos alpha. Okay, so write down the formulas, that's it. For now, just write down the formula. Now let me show you how to apply these formula in the question. Okay, let me show you that. Find general solution. Okay, we are going to be doing many questions in this. So the first question, finding general solution. Sine theta is equal to 1 by 2. Okay, we know how to find the principal solution for this, right? You can easily find the principal solution, that theta will be equal to pi by 6 in the first quadrant, and we have another one in the second quadrant, right? So sine theta is equal to 1 by 2, you can write its principal solution. We want to write its general solution. Basically, I want all the solutions of this equation, right? There are infinite solutions to this equation and we need all of them. Okay, so how do we write it? First of all, can you write 1 by 2 as sine of something? That's your first approach. Can you write 1 by 2 as sine of something? So yes, you can write 1 by 2 as sine of pi by 6 or sine of 5 pi by 6, that also works. Okay, you can write 1 by 2 as sine of pi by 6 or you can write sine of 5 pi by 6, that also works. So now we have that format, that sine theta is equal to sine of alpha. So theta will be equal to what? N pi plus minus 1 raised to the power n times alpha. This will be the value for theta. Theta is equal to n pi plus minus 1 raised to the power n times alpha, right? This is the formula for sine theta is equal to sine alpha. So this is the general solution. Now we have all the solutions of this equation. Just put different values of n and we get all of the solutions of this particular equation. I hope all of you gets it. Okay. So as I told you, even if you write 1 by 2 or even if you write 1 by 2 as sine of 5 pi by 6 and then you write its general solution, that also works, right? Sine theta is equal to sine of 5 pi by 6, sine of 5 pi by 6 is also equal to 1 by 2. Okay, so now again you can write theta is equal to n pi plus minus 1 raised to the power n times 5 pi by 6. This is also the answer. And basically these two looks different. These two looks different but are same. Yes, they are same. They are the same angles, everybody. These two looks different but they are giving us the same angles. See, if you put n theta, right, if you put different values of n, the values of theta that you get, right? Suppose if you put n as 0, n as 1, n as 2, n as 3, what angles are you getting? If you put n as 0, we are getting theta is equal to pi by 6, right? This becomes 0, minus 1 raised to the power 0 will be plus 1. So plus 1 into pi by 6, we get pi by 6, correct? If you put n as 1, so we get pi minus pi by 6, which is what? 5 pi by 6. If you put n as 2, we get theta is equal to 2 pi plus pi by 6. 6 2s are 12, 12 plus 1, 13 pi by 6 and so on, right? Now here also try putting values of n. You will be getting same set of angles. See, if you put n as 0, if you put n as 0, we get 5 pi by 6. Are we also getting 5 pi by 6 over here? Yes, we are also getting 5 pi by 6 over here, right? So if you put n as 0, we get 5 pi by 6. If you put n as 1, what do we get? We get pi minus 5 pi by 6, which is pi minus 5 pi by 6, right? Which is pi by 6 only, and so on. Here we get pi by 6. Here also we have pi by 6. So what I am saying, that this answer is also correct. This answer is also correct. Okay, both of them are giving the same set of values of answer. So either you can write this or this. Just follow the concept very properly. Okay. So if sine theta is equal to 1 by 2, we can write 1 by 2 as some angle, sine of what? So if we can find the principal solution, we can easily write the general solution. So you know that its principal solution is pi by 6. You can generalize it now. that theta is equal to n pi plus minus 1 raised to the power n into pi by 6. You know that its principal solution is also 5 pi by 6. You can generalize it like that. Okay. Let's move on to the next example. Like 2 cos theta plus 1 is equal to 0. Let's write the general solution of this equation. So 2 cos theta plus 1 equal to 0. So here we have cos theta is equal to what? Here we have cos theta is equal to minus 1 by 2. Okay. Now write minus 1 by 2 as cos of some angle, so that we can form that form of cos theta is equal to cos alpha. So minus 1 by 2 can be written as cos of what? 5c. Let me write it. We know that cos pi by 3 is 1 by 2. Cos pi by 3 is 1 by 2. Right? We know that. And we are getting negative values. So we get negative values either in the second quadrant or in the third quadrant. For cos is negative either in the second quadrant or in the third quadrant. Cos will give you negative values. So we know that cos of pi by 3 is 1 by 2. So cos of pi minus pi by 3 will be minus 1 by 2. Right? Cos of pi minus pi by 3 is minus 1 by 2. And pi minus pi by 3 is what? 2 pi by 3. Cos of 2 pi by 3 is minus 1 by 2. We know this. So if you know this thing that cos of 2 pi by 3 is minus 1 by 2. So now you can write minus 1 by 2 as what? You can write minus 1 by 2 as cos of 2 pi by 3. So now we have that form, cos theta is equal to cos alpha. So theta will be equal to what? Theta is equal to 2n pi plus minus alpha. 2n pi plus minus 2 pi by 3. This is the general solution of this equation. See, here I have applied the formula for cos theta is equal to cos alpha. Cos theta is equal to cos alpha. So here theta is equal to 2n pi plus minus alpha. That's the thing. Okay. Okay. Clear? Let's move on to the next example. Question. Okay. Cosec theta is equal to minus 2. We need to write its general solution. Cosec theta is equal to minus 2. So you can simply write cosec theta. If cosec theta is minus 2, sin theta will be what? It implies that sin theta will be minus 1 by 2, because sin is the reciprocal of cosec. Now can you write minus 1 by 2 as sine of some angle? So we can express it as sin theta is equal to sin alpha. Right? So sine will give you negative values in the third quadrant or in the fourth quadrant. Give me any one of those angles. So again we know that sine of pi by 6, that is 1 by 2. Okay. This is in the first quadrant. In the second quadrant, which is pi minus pi by 6, there also sine will give you positive value. Sine will give you negative value at third quadrant, which is pi plus pi by 6. The third quadrant angle. There sine will give you negative value. So sine of pi plus pi by 6 is equal to minus sine pi by 6, and that is basically minus 1 by 2. Okay. So sin theta is equal to minus 1 by 2. I can write this angle minus 1 by 2 as pi plus pi by 6, which is basically 7 pi by 6. 7 pi by 6. Okay. So sin theta is equal to sin 7 pi by 6. Okay. So minus 1 by 2 is what? 7 pi by 6. So sin theta is equal to sin 7 pi by 6. Are we clear, everybody? Okay. So now we can generalize this thing. We can say that theta is equal to n pi plus minus 1 raised to the power n times 7 pi by 6. Theta is equal to n pi plus minus 1 raised to the power n times 7 pi by 6. This is our answer for this question. Okay. So if we know these three formula, we can solve any equation like this. Okay. We can easily solve any of the equations. Like suppose if I write tan theta plus root 3 is equal to 0. What are the general solutions of this equation? So here I can say if tan theta plus root 3 is equal to 0, it implies that tan theta is equal to minus root 3. Now tan theta is giving you negative values. Tan theta is minus root 3 in which quadrant? Either in the second quadrant or in the fourth quadrant. Give me any one of those two angles. So you can provide me an angle in the second quadrant, okay, or fourth quadrant, whatever. So we know that tan is equal to root 3 at pi by 3. So this is basically, you can write minus root 3 as tan of pi minus pi by 3. Tan of pi minus pi by 3. Tan of pi minus theta is minus tan theta. Tan of pi minus pi by 3 is minus tan pi by 3. Basically that is minus root 3. Okay, so we have tan theta is equal to tan of pi minus pi by 3, which is tan of 2 pi by 3. Okay, tan theta is equal to tan of 2 pi by 3. So now we can generalize this thing. We can say that theta is equal to n pi plus alpha, n pi plus 2 pi by 3. This is the generalization of tan, right? We know that tan theta is equal to tan alpha. If tan theta is equal to tan alpha, theta is equal to n pi plus alpha, right? So if tan theta is equal to tan 2 pi by 3, theta is equal to n pi plus 2 pi by 3. Simple, very, very simple. So now I am giving you some homework question. Find general solution. Just some practice question to remember all of these things. Okay, find general solution. Question number 1. Sine theta is equal to minus root 3 by 2. Okay. Question number 2. 2 times cos theta minus 1 is equal to 0. Okay. Question number 3. 2 sine theta plus root 3 is equal to 0. Okay. Question number 4. Cot theta plus root 3 is equal to 0. Okay. Question number 5. Cot theta minus 1 is equal to 0. Cosec theta, okay, cosec theta plus root 2 is equal to 0. So basically here cosec theta is equal to minus root 2. So you can convert it to sine. Sine theta will be minus 1 by root 2, and you can easily find the solution of this equation as well. Okay. 7th, tan theta, okay, plus root 3 is equal to 0. So try all of these questions for your homework, okay, so that you can easily remember all of these formulas. So just basic formulas we have talked about in this class. Okay, one more formula I need to give you, but that I will give you in the next class, and in the next class we will practice more questions on it. So almost the theory part is over. Okay, but yes, there can be different types of equations. In today's session we have only discussed about the basic understanding, right? So we have only developed basic understanding of trigonometric equation in today's session. In the next session we will be doing lot more practice on this particular chapter. So see you all in the next session. Till then, this is your maths teacher Kundan Mankad signing off. Tada, bye bye, have a great day everyone.